Here's an example of another problem that finds a possible power function, but the wording is a little different, so I wanted to show you this. It says find a possible power function with the properties given, and instead of given xy points, it gives function notation, where it says f of -6 equals 36 and f of -2 equals 4/3. So for the first step, you need to understand how to pull that function notation, as in -6 is the input, which is x, and 36 is the output, which is y. So that f of -6 equals 36 would be the same as the coordinate point -6, positive 36. And likewise for the second one, that would be the point -2 and 4/3. So now that we've identified the 2 points, we can move forward. So the next step is to take and plug those xy values into 2 separate power functions. So again, it's y equals k times x to a power. So if we plug in our x and y values, we get 36 equals k times -6 to a power, and 4/3 equals, nope, messed that up, didn't I? Those are backwards, sorry. Y equals k times x to a power. So 4/3 equals k times -2 to a power, sorry about that. So now we have 2 separate power functions. So then we will move on to setting up the ratio of matching components. So that's where we take the right sides of the equation and make a ratio. So k times -6 to the p over k times -2 to the p equals, and again, here, remember, it's extremely important that however you pull those numbers from those parts to make the ratios, that you're pulling the same order. So if we put -6 to the p on top, we've got to put 36 on the top of the ratio on the right side. So 36 over 4/3 is the way that sets up. We'll cancel those k values. And I'm going to combine the -6 over -2. In this instance, it's actually going to help us because -6 over -2 is just 3. And then if I clean up the right side, it's a fraction and a fraction, so we've seen this. So it's like 36 divided by 4/3, which is 36 times 3/4, which simplifies to 27. So our simplified proportion that we made with the 2, the ratio pieces from the power functions give us that 3 to a power equals 27. Well, 3 to the 3rd power is 27, so that would make our power a value of 3. So this is a cubic function. So once we found p, we'll use that p value and plug it back into either one of the equations, the power functions that we made before. I'm going to just use the first one, frankly, because it doesn't have a fraction in it, and put 36 equals k times -6 to the 3rd power. And when you do that, you get 36 equals k times -216. If you do -6 to the 3rd power, -6 times -6 times -6, get -213. And then if I divide both sides by -213 and simplify, I get that k is -1/6. So that's my constant, the coefficient that's multiplied in front of the power function. So I combine those two. So I take my k value and my p value, and I go to the formula for a power function, which again is y equals k times x to the p, and I plug those things in. So my power function is -1/6 x to the 3rd power.